Welcome to week 2, Descriptive Statistics. So in this video lecture, I will cover descriptive statistics in general and two types of descriptive statistics, numerical and graphical summaries. And then we'll discuss some popular descriptive statistics used for different types of variables. Descriptive statistics, also called summary statistics, are simple statistics for describing the characteristics of the study sample. All right, so once we complete our study, we finish our measurement, so we'll get data on our study sample. The first job for our data analysis is to just see what kind of study sample we have got. Okay, so descriptive statistics leads to immediate profiling of the study sample and is the necessary first step of a statistical data analysis process. A statistical data analysis process usually consists of univariate, bivariate, and multivariate statistics. And descriptive statistics usually is the first step. And descriptive statistics also give us some idea about to what population we can generalize our findings to. Okay, it must be similar population to the characteristics of our study sample. There are two types of descriptive statistics, numerical and graphical summaries. For example, numerical summaries have like mean or frequency, and graphical summaries, for example, histogram or a boxplot. And of course, there are some descriptive statistics kind of have both features. For example, a stem and leaf plot, which let you visualize the numerical values and the shape of the distribution. When we decide what type of descriptive statistics we should use for a variable, the types of variable are very important. Okay, so numerical variables are those that must be described by using numerical values, and categorical variables are those that can be described by categories. So in general, if you look at the diagram on the right, we can classify data into categorical data and numerical data. For example, marital status is a categorical variable. And in numerical variable, we can have discrete variables, for example, number of children, so that count data, or continuous variable such as weight or age. Okay, so when you have different types of variables, then you need to find appropriate types of descriptive statistics. Descriptive statistics for categorical or discrete variables, commonly used ones are frequency, percentage, bar chart, pie chart, or frequency distribution. For continuous variables, commonly used are mean standard deviation, histogram, or boxplot. And SPSS can be used to produce various numerical or graphical descriptive statistics of a study sample with ease and elegance. For example, you can use the descriptive statistical module and analyze, or you can use the chart builder and the graphs. So here's an example of a table. It contains frequency and percentage of a categorical variable class rank. There's a column called the valid percent. That is the percentage they also take into account of the missing data. And then the cumulative percent is actually based on the valid percent. Okay, so it gives you a good idea about in each category how many observations fall in that category and in what is the percentage is relative into the whole sample. Okay. Here's a bar chart for primary sector in 2010. So it shows you the distribution of a categorical variable. And the advantage of a bar chart is really it immediately shows which category has the highest bar. So it really stands out. Okay. Of course, we can make a bar chart more complicated. For example, this is an example of the so-called side-by-side bar chart, also called a cluster bar chart. It is really nice to visualize the frequency of a categorical variable in two groups at different levels of another category variable. So it's very informative. It actually go beyond the univariate statistics, more like a bivariate analysis. Okay, it starts looking to the relationship among different variables. A pie chart is another tool for visualize categorical variable. And the advantage of a pie chart, it is quickly shows how large each category is in relative to the entire sample. Okay, so and a bar chart it doesn't really make that easy for you to see, but a pie chart really tells you the relative percentage of one category in relative to the entire sample. And this table is a very detailed descriptive statistic for continuous variables, and there's lots of them. They have mean, median, standard deviation, variance, minimum, maximum range, interquartile range, skewness, and kurtosis. Okay, I will provide additional websites and videos for more detailed information on these descriptive statistics, and you can also read our textbook to understand these statistics. We are going to just focus on the mean standard deviation, and sometimes we also include the median and minimum, maximum, and as needed. Okay. So here is the histogram of age, and so the histogram is really the graph of a probability. It's a discrete version of the probability density function. But once we plot the histogram, usually we can add a probability density function of a normal distribution, and this allows us to compare the histogram we produced and how close it is to a normal distribution. Okay. And the normal distribution assumption of the data is very important for us to perform many statistical tests later on. Okay. And here is actually a kind of a variant of the histogram. It's a back-to-back histogram. You can generate this in SPSS. It gives you a nice to compare the distribution of the same variable in two different groups. Okay. And here is a horizontal box plot. It contains the minimum first quartile, that's the 25th percentile, median third quartile, that's the 75th percentile, and the max. And these are called a 5-point description or summary of the distribution. Once you have these 5 summary statistics, you have a pretty good idea about the distribution. Okay. And also you can make side-by-side box plot, and very good tool for us to compare the distribution in two groups. You can even make it for more than two groups, and this is really a good visual before an ANOVA analysis. So the question about how to do all these, and please see the step-by-step instructions and the videos provided later on. And another tip is really before you do multivariate statistical analysis, the first step is visualize your data. So people are saying generate many graphs to look at your data first before you actually do more sophisticated analysis. That's again underscore the importance of descriptive statistics. Okay, that's the end of this lecture. Thank you.